Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. Long before clocks began to tick or calendars were born, long before humans wondered what an hour truly meant, there was light, moving, dancing, endlessly drifting across the dark silence of space. Light has always moved with purpose, though not in haste. It travels not to reach a place, but because that is its nature, to move at the exact same speed, no faster, no slower, through the deepest vacuum and the thinnest air. That speed, 458 meters per second, became more than a number. It became a ruler for the universe, a quiet metronome for time itself. Scientists once believed that time was absolute, like a river flowing independently of everything else. But when they looked closely, they saw that time curved and bent in the presence of mass and energy, and they discovered something astonishing, that light was not just a participant in this cosmic theatre, it was the script by which time performed. When light travels, it doesn't simply move, it defines the path that time takes. In every corner of space, in every flicker of a star or flash of a lightning bug, the speed of light is whispering to the universe how fast or slow time should feel. Imagine you're standing beside a calm lake at dawn. The sun has just begun to rise and its rays glide across the water. They reach you effortlessly, without you noticing the journey they've made. But those rays, those photons, have been on a precise mission. From the core of the sun to your eyes, they have moved unwaveringly, obeying the speed limit the universe has written into its bones. And yet if you were moving, walking, running, or even soaring in a spaceship, those photons would still meet you at the same pace. That's the great mystery. No matter how fast you go, the speed of light never changes. It doesn't speed up to catch you or slow down if you're still. It is the anchor, the still heartbeat behind all the movement. It is as if the universe has chosen light as its reference point, the golden thread tying space and time together in a delicate fabric that we're only beginning to understand. Centuries ago, we thought light was instant, that it simply appeared the moment something bright came into view. Galileo tried to measure it with lanterns on hilltops, hoping to catch a delay. He couldn't. It was too fast for him. But the light still held its secrets quietly, waiting for the world to build telescopes and clocks precise enough to listen. When scientists watched how light curved around the sun, they realized something extraordinary. Light was not just a traveler. It responded to gravity's pull, not in the way a stone falls to the earth, but in how its path bent ever so slightly. That gentle bend told us something else, that gravity wasn't just pulling on matter, it was shaping the space light moved through, and since time and space are woven together, it was shaping time as well. And so light revealed a deeper truth, that the closer you are to something massive like a planet or a star, the slower time flows for you compared to someone farther away. The universe, it turns out, doesn't keep a single clock. We now build our most accurate clocks not with ticking hands or gears, but with light itself. Atomic clocks, the guardians of time, use the vibration of atoms and the energy of light to mark the passing of seconds with such precision that they would only lose a second every few billion years. These clocks have shown us something remarkable. Even a tiny change in altitude, just a few centimeters up or down, can make time tick ever so slightly differently. On mountaintops, time runs a touch faster than in valleys. Your head ages faster than your feet. It's a truth so gentle and strange that it feels like a dream. The earth is quietly stretching and squeezing time, and light is there to show us how. When we send spacecraft deep into the solar system, we guide them not by watching where they are, but by timing how long their signals take to return. Those beams of light become rulers, measuring distance through time. If a signal takes longer to return, the craft is farther away. But if gravity slows the light, we must account for that too. In this way, the universe reveals that it isn't just about where things are, it's about when they are. Distance becomes a question of time, and time becomes a matter of how light travels. The stars that twinkle above you may have died long ago, and yet their light still travels, still brings their story to you. What you see is not the star now, but the star then, a whisper across time. In this way, light becomes a messenger of the past, a soft reminder that every glance into the night sky is also a look backward through time. In every laboratory, telescope, and quiet corner of Earth, scientists continue to listen to light. They bend it through prisms, bounce it between mirrors, and stretch it across space. Each experiment brings a new whisper, a new insight. We are slowly learning that light doesn't just travel through time, it writes time into the very walls of the universe. It is a constant, not because it is unchanging, but because it is chosen. The universe leans on light the way a poem leans on rhythm. Without it, nothing would align, no seconds would pass, no moments would hold their shape. Every breath you take, every beat of your heart, every blink of your eyes is guided by the gentle law that light must move at the speed it does. Not one pulse faster, not one sigh slower. Now imagine you are floating alone in the darkness between stars. No sound, no wind, just silence and stars. And yet you're not truly alone. Around you light is moving, passing you, reaching you, brushing your skin in particles too small to feel. That light, perhaps from a distant galaxy, has been travelling for millions, even billions of years. It has not tired, has not slowed. It moves because it must. And in that movement, it brings with it a clock, a rhythm, a truth that links you to everything else. The stars, the earth, the people who came before and those who will come after, all are bound by this invisible metronome. The speed of light connects them. And you, in this moment of stillness, are part of that connection. So when you look up again, when the sky is dark and the stars are shimmering, remember that you are seeing not just light, but time. You are witnessing how the universe measures itself. You are holding a thread that stretches across eons. And though it may seem delicate, it is firm, it is quiet, but it is certain. The light you see tonight is not just a glow, it is a measure, it is a clock, it is the first and final whisper of time itself. Consider this: when sunlight touches your face, the photons making that contact were born in the heart of the sun perhaps thousands of years ago. They struggled through the dense plasma of the solar core, bouncing and ricocheting their way outward in a journey that took centuries. But once they escaped into space, they raced straight toward you in a little over 8 minutes. To you, they took their time, but to them, if they could feel time at all, the moment of their birth and their arrival was the same. Time didn't pass for them. They existed only in motion. It's almost poetic how light skips over time entirely, while we are trapped inside it, measuring it, feeling it, aching inside its slow march. Light does not age, it does not remember, and yet it carries the memory of everything it touches. This is why we use light to look back into history, not just human history, but cosmic history. When astronomers point telescopes deep into space, they are not just seeing far away, they are seeing long ago. Because of light's finite speed, the farther we look, the older the light we catch. Some of the galaxies we observe are no longer there in the form we see them. They may have changed, collided, or burned out, but the light still travels, whispering stories of how they once were. It is a strange kind of truth that we can never see the universe as it is, only as it was. Even the moon you see tonight is not now, it is 1.3 seconds ago. The sun, 8 minutes ago. The stars, centuries, millennia, eons. Light becomes a diary, one that never forgets, even as it feels no time itself. There is something deeply emotional in this. It means that in some way, nothing ever truly vanishes. The light it gave off, the reflection it cast, the energy it flared, all of it continues to move outward, endlessly, softly, carrying a version of that moment forever. A child's laugh on a sunny day, bouncing off a wall, glancing off a window, lost in the atmosphere. Its photons are gone from here, but the energy remains somewhere. In the vacuum between stars, in the distant threads of cosmic background radiation, the light of our past still moves forward. Even the light from the birth of the universe, what we call the cosmic microwave background, still travels today, cooled and stretched by the expansion of the cosmos. It is the baby picture of time itself, and we can still hear it, like a lullaby echoing from the cradle of existence. The interplay between light and time becomes even more delicate when we consider how gravity affects their dance. Gravity does not just pull, it warps. And when gravity bends space, it also bends time. In regions of intense gravity, like near a black hole, time slows dramatically. Light near such massive objects struggles to escape, and sometimes it never does. That boundary, the event horizon, is the place where even light cannot outrun gravity's grip. And if light cannot escape, time, in a sense, stops there. Outside observers see light stretch and fade like a memory that can't quite reach them. It's as if time itself is swallowed whole. In these places, we find the edge of what we understand. The speed of light remains constant, but what that speed means begins to twist. Time, once thought to be a straight line, becomes a soft spiral, bending around things too massive for us to resist. And yet, we use this same fragile relationship to keep track of time more precisely than ever before. GPS satellites must account for both their motion through space and their height above Earth's surface, because both affect time. They are moving fast, which slows their clocks. But they are also high above Earth, where gravity is weaker, which speeds them up. These two effects nearly cancel, but not quite. So we adjust them constantly, letting the light signals they send down to us reflect not just where we are, but when we are. Without these corrections, our locations would be off by miles. So even in everyday life, light and time are holding hands above our heads, balancing their effects in a quiet, cosmic conversation. There is something comforting in this balance. It tells us that the universe is not chaotic, but composed. That even in its wildest corners, where stars explode, where black holes spin, where galaxies collide, the laws of light and time still hold. They still care, they still hum the same gentle tune, and that tune can be heard not just in laboratories or space missions, but in the silence of your own room. Each time you turn on a lamp, Light travels from filament to wall, from ceiling to floor, from corner to corner, all at the same steady pace. You cannot outrun it. You cannot make it move faster. It simply is, and in its being, it keeps everything else in check. Now, imagine a clock made entirely of mirrors and a single beam of light. The beam bounces between the mirrors, tick, 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 marking time not with sound or gears, but with light's own rhythm. Move that clock faster, and the light must travel farther between each bounce because the mirrors themselves are moving. But the speed of light can't change, so the ticks slow down. The clock in motion ticks more slowly than one at rest. This is not fiction. It is special relativity, and it has been proven time and again. Light becomes the arbiter of time, not by choice, but by nature. And in doing so, it shows us something profound, that time is not a constant beat, but a stretchable fabric, pliable and tender, moulded by motion and gravity and light. All of this comes back to something very human, the passage of time as we feel it. Why does a moment feel long or short? Why do some hours drift like leaves, while others race like wind? We may never fully know, but we do know this. Our biological clocks, our perception, our memories, they are shaped in part by the light that surrounds us. Morning light triggers wakefulness. Evening dimming brings rest. Our bodies are tuned to light's rhythm, evolved through millennia beneath its constant gaze. Light doesn't just move through time, it teaches us how to feel it. It paints the edges of our days, it wraps the hours in colour and warmth. So perhaps time is not something we hold, but something we follow. Perhaps we are dancers in light's long ballet, twirling softly through seconds and years, guided by a music we barely hear. The speed of light, fixed and true, becomes the tempo. It sets the pace. And as we move through this world, slowly, unknowingly, we keep in step, always, with the light. Now let us move gently toward the final curve in this river of thought, where light and time begin to settle into something more personal, something you can almost feel in your chest, like a quiet heartbeat that echoes the universe itself. We've followed light across galaxies, seen how it bends through gravity and stretches across time. But the most intimate truth of all is this: light is with you, always. It's not only out there in the stars, it lives inside you. Every second your eyes drink light and your mind turns it into sight. Your skin warms under sunlight. Your circadian rhythms, your sense of waking and sleeping, your moods, your sense of presence in time, all of it is anchored in the rhythm of light. Without it, your body forgets how to tell time. People who live for long periods in darkness or artificial light feel untethered, as though their thoughts begin to drift without direction. The speed of light may be constant, but the feeling of time it brings is deeply human. And yet there is something even more profound. Inside your cells, tiny organelles called mitochondria respond to light, not just visible light, but deeper, more subtle forms like infrared. Light stimulates processes of growth, repair, and communication. In plants, light is food. In humans, light is instruction. It whispers to your biology, telling it when to rest, when to heal, when to release energy. Your body is not separate from the universe. It is an echo of it. The same photons that warm a leaf, that paint a sunrise also pass through you, guiding invisible clocks that tick in every organ, every cell. Time, it turns out, is not something far away. It is something you carry within, like breath, like pulse. When you look at the stars, you are doing something miraculous. You're not just seeing distant points of light, you're absorbing messages that have travelled billions of years to meet you. Each twinkle, each beam is a letter written in the ink of light and sealed in the envelope of time. The light from Andromeda, the nearest large galaxy, left its home over 2 million years ago. It is only now brushing your eye, and though it has travelled so far, it arrives unchanged. That distance, that time collapses into a moment of awe. You're standing in the present and yet receiving the past in real time. This is the closest we come to time travel, to see the light of what was and to hold it for a second before it vanishes forever. Even in your memories, light has a role. When you recall the past, you often see it, not as words, but as images. The way the sun looked on a particular morning, the colour of a room, the shadows on someone's face. These are all fragments of light, encoded into memory. Your brain uses patterns of light to build the theatre of your past. And so light becomes not just a carrier of time, but a container of it. It holds emotion, it carries meaning. The golden hour glow of a childhood afternoon, the soft flicker of candlelight during a moment of grief, the shimmer of the sea on a joyful day. These are the ways we remember time. And though the actual seconds may be gone, the light remains, etched into our minds like gentle waves on sand. In this way, time and light are not just physical principles, they are emotional landscapes. The sunset does not just signal the end of a day, it feels like closure. The first light of dawn does not merely brighten the sky, it feels like hope. These feelings arise because your body and mind respond to light as a rhythm, a poem written across the hours. And when that rhythm is broken, when the sky stays dark for too long or the lights never dim, your inner sense of time begins to falter. You may feel lost, restless, or tired. Light anchors you. It tells you where you are in the story of the day. Without it, time feels like it has no beginning or end. And this brings us quietly to one more truth. As the universe expands, the light from distant galaxies becomes stretched, elongated into redder wavelengths. This redshift is not just a visual effect, it is a slowing, a lengthening of time itself. The farther away a galaxy is, the older the light, and the more it has been stretched by the expansion of space. It means that the universe is not only growing, it is. And we can see that aging process in the fabric of light. The cosmic microwave background, that ancient whisper from the birth of time, has been cooled and stretched across space for over 13 billion years. And yet it still surrounds us. It still speaks. It still tells the story of a moment when the universe became transparent and light began to roam free. Even now, scientists build delicate instruments to measure that light. They study its patterns, its faint fluctuations, like archaeologists reading ancient script. From it, they learn how time began, how space expanded, how the first stars formed, how galaxies danced into being. All of this from light. All of this through time. And yet, even as we understand more, the mystery only deepens. Why does light move as it does? Why can nothing move faster? Why is time woven so intimately with motion, with space, with gravity, with the things we cannot see? These are questions with no final answer. And maybe they don't need one. Maybe the wonder is enough. Maybe the rhythm of light and the softness of time are their own kind of explanation, a lullaby for the mind. So now, as we come to rest from this long, gentle journey, let's return to something simple. Close your eyes, breathe slowly, the light is still moving. Somewhere right now, a photon is being born in a distant star. It will travel across unimaginable darkness, never changing speed, never forgetting its path. May pass a black hole and bend, may weave through a galaxy and scatter, may someday meet the eye of a child not yet born, and in that moment complete its journey. This is what light does. It connects, it carries, it continues, and with it time moves, not because it must, but because light tells it how. You too are part of that journey. Every breath you take, every thought you have, every second you live is part of this great unfolding. You are not outside of it, you are within it. The speed of light, so exact, so lent, gives you the seconds you count, the years you remember, the rhythm of your life. And though you cannot feel it pass beneath your feet or hear it sing through the trees, it is always there, a thread of certainty in a world of change, a quiet guide in the symphony of time. And perhaps that is the most beautiful part of all, that something so fast, so constant, so old, can also be so gentle. Beneath the soft velvet of the night sky, where stars bloom like frost on the dark glass, time moves differently. Not in the way we mark it with watches and ticking seconds, but in a deeper rhythm, one tied to the turning of the earth, the spinning of galaxies, and the quiet language of starlight. Long before humans built clocks or wrote calendars, they looked upward, and in the sky they saw time, the slow arc of the moon, the gentle wandering of planets, the steadfast return of constellations. All of it told a story that repeated each night, each season, each generation. For early civilizations, stars weren't just decoration. They were guides, memories, and promises. They told farmers when to plant, travelers when to sail, and children when to sleep. Time beneath the stars was felt, not measured. It was a whisper through the leaves, a cool breeze at dusk, the hush before dawn. It asked nothing and offered everything. Let's imagine the first person who truly waited for a star, noticed when it rose, noticed when it vanished. Perhaps they sat quietly, feeling the earth breathe, sensing something sacred in the sky's order. They didn't know the word orbit or understand gravity, but they knew that Sirius always returned, that Orion stretched across the winter sky like a story being told again and again. To them, stars were not distant suns, they were companions, and over generations, this relationship grew. The stars became maps, calendars, storytellers. Monuments were built to follow them. Stone circles and shadow tracking towers rose across the earth, not in search of power, but in reverence to time as seen from below. Time beneath the stars became a sacred rhythm, the oldest lullaby we know. Today, science tells us the stars are incredibly far away, that their light travels for years, centuries, even millennia to reach us. The nearest star beyond the sun is over 4 light years away. That means when we look at it, we see it as it was 4 years ago. Many stars we see are much older. Some died long before the first cities rose on Earth, but their light still moves through space, unchanged, still telling us their final story. That's the gift of starlight. It carries the past. It delivers time across impossible distances. It is memory moving. So when you sit beneath the stars, you are not just seeing light, you are seeing echoes. You're witnessing moments that happened long ago, arriving now like letters sent across the sea. The sky becomes a book and each star a page. There is a kind of peace in this, a stillness that reminds us how patient the universe is. Our days may feel rushed, our minutes crowded, but the stars are never in a hurry. They drift at their own pace, unbothered by urgency. Some wobble gently in their course, tugged by orbiting planets. Others blink with the pulse of nuclear hearts, swelling and contracting over long spans of time. A single blink of a variable star might take years. A supernova may explode in seconds, but its light can shine for centuries. Time here is not measured in seconds, but in brightness, in colour, in silence. The stars remind us that change doesn't need to be loud, that even the smallest shimmer can mean something eternal. Above you, even now, the stars continue to speak. But they speak in a language not of words, but of photons, wavelengths, shifts. Astronomers learn to listen, to read the colours, to detect the sway of motion, to understand how old a star is, what elements it holds, how fast it is running away from us. Because the universe is expanding, most galaxies drift farther from us each moment. And as they do, the light they send stretches, reddens. This redshift tells us how fast they flee, how far they've gone, how the cosmos has changed since their message began. In this way, time beneath the stars becomes a science of distance and delay. We do not just learn where something is, we learn when it was. Light again becomes the measure. But the stars offer more than data, they offer perspective. To lie under them, to let your eyes wander into their endless field, is to remember how brief we are, how young, how small, and yet in that smallness something beautiful emerges, a sense of belonging, because we are not separate from those stars. We are made of the same elements they forged in fire: carbon, nitrogen, oxygen, iron. The atoms in your hands were built in the belly of a dying star. And so time beneath the stars is not just about watching, it's about remembering where you came from. You are stardust, still glowing, still thinking, still feeling the pulse of a sky that made you. In ancient stories, people believed stars were eyes of gods, or souls of ancestors, or jewels set in the dome of night. Those stories may have changed, but the wonder remains. Even now we name stars, chart their patterns, make wishes on them. In cities where the sky glows with artificial light, we build observatories and send telescopes into orbit, not because we have to, but because we still want to see. We still long to feel the rhythm of time in the heavens, to be part of a story that is larger, slower and more constant than anything we can create. We still ache for that connection to the stars that watched over our earliest dreams. So next time you look up, whether from a mountaintop or a quiet backyard, pause. Let the stars be more than background. Let them be time. Feel their age, sense their distance. Know that what you are seeing is both far away and long ago. Let their light wash over you like a soft wave from the past, touching your present. There, beneath the stars, time slows. Not because the seconds change, but because your heart begins to beat in rhythm with the ancient sky. And for a moment, you are no longer rushing. You're still. You're timeless. Let's go deeper now, into the gentle layers of how stars do not just shine above us. They shape how we understand time itself. For many centuries, humanity measured time by the heavens. The rising and setting of the sun gave us days. The phases of the moon gave us months. The return of constellations marked the seasons. The entire concept of a year was written into the sky before it was ever written on a page. Even today, the calendar we follow is not built from machines, but from cosmic motions, tilts and orbits and alignments that trace arcs too grand for any clock. Time beneath the stars is not just ancient, it is the foundation of all timekeeping. Before we knew the Earth moved around the Sun, we watched the sky shift night by night and found in it a rhythm, predictable, silent, trustworthy. The stars, like old friends, always returned. But their return was not just a signal of time passing, a sign of Earth's place in the cosmos. When a star rises earlier each night, it means the Earth is moving, tilting, orbiting. The stars aren't changing, we are. The sky becomes a mirror, reflecting our journey through space. When we see Orion appear on cold evenings, it is not just a winter pattern, it is a message. We are here, again, in this part of our orbit, our celestial loop. And in that return, there is comfort. It means the Earth has not drifted, the stars still know us. Time through their light is still flowing as it should. It's a kind of cosmic reassurance, soft as a lullaby whispered through the dark. Astronomers use this relationship to build tools more precise than any sundial or pendulum. By observing the timing of starlight, we can measure Earth's rotation to fractions of a second. If the Earth slows down even slightly, as it does over centuries due to tidal friction, the stars tell us. We adjust our clocks accordingly. We even add leap seconds to keep in step. In this way, time beneath the stars is not only symbolic, it is scientific. It is real. It governs satellites and telescopes, space missions and time zones. Without starlight, our systems of time would drift. But with it, they remain anchored in something ancient and true. Beyond the practical, though, there's a deeper poetry to this. The light from stars arrives in silence. It doesn't carry sound or scent or touch. It carries only itself, its colour, its angle, its timing. Yet from this whisper of a photon we learn everything. We learn a star's age by how blue or red it glows. We learn its temperature, its chemical makeup, its movement through space. And because light takes time to travel, we learn not what the star is, but what it was. This is the tender paradox of astronomy. We are always looking into the past. No matter how powerful our telescope, we cannot see a star as it is now. We can only see what it once was, and from that imagine what it might be. This delay is not a flaw, it is a gift. It allows us to see a kind of history written in light. When we observe a galaxy 10 billion light years away, we are seeing it as it was 10 billion years ago, before Earth existed, before the Sun was born. It is like opening a time capsule, not buried in soil but hung in space. And when we string these observations together, across different distances and directions, we begin to build a story, a quiet unfolding of the universe itself. We see how galaxies formed, how stars lived and died, how structures grew like frost patterns across a window pane, all of it traced by light, all of it watched from this small spinning world beneath the stars. Sometimes a star flares suddenly, a nova, a supernova, a sudden eruption of brightness that changes the sky. These events are rare, but when they happen, they ripple through time like a bell tolling across a valley. A star that had been steady for millions of years suddenly screams, and its scream travels outward for all to see. We see it when the light reaches us, days, years, or centuries later, and we measure that scream. We read it like a poem. We learn from it how matter behaves at its limits, how time behaves at its edges. In this way, the drama of the stars becomes our textbook, Their violence becomes our understanding, and even in their death, they give, they teach, they light our path forward. And yet it's not just stars. The moon too plays her part in the time beneath the sky. Her phases mark the weeks, her cycles regulate tides, her gravity gently pulls on oceans, shaping the rhythm of Earth's water, which shapes the rhythm of life. Ancient people followed her closely, marking festivals and rituals by her glow. Even today, lunar calendars guide billions. The moon is not just a rock in the sky. She is a clock, slow and steady. Her face changes, but her cycle endures. And when she eclipses the sun, casting a sudden darkness, time feels like it pauses. The world hushes, light vanishes, and in that moment, we remember that all time is borrowed from the stars. What does it mean to live beneath such a sky? To feel time as something cosmic and alive? It means that you are never separate from the universe. Every moment you breathe, the stars are moving, the earth is spinning, the galaxies are expanding. Your time is not just your own. It is part of a larger rhythm. When you pause to look up, you are syncing your life to something far beyond you. And though you may not feel it, that sync shapes you. It shapes your biology, your emotions, your dreams. Even the sleep-wake cycle in your brain responds to the light of the sun and the dark of the stars. Your body listens to the sky, even when your mind forgets. So let the stars remind you. Let them slow your heart, soften your thoughts, bring you back to the quiet truth that time is not a machine. It is not a race. It is a song, played slowly, beautifully across the stage of the night. The stars are the notes. The darkness is the page, and you, lying beneath it, are part of the music. You don't need to understand it all. You only need to feel it, to let the light fall gently onto your face, to let your breath rise and fall in time with the turning of the earth, to let the silence of space fill you with something calm. That is time beneath the stars. Not a clock to watch, but a wonder to feel. Now, in the soft twilight of this journey, we come to the most delicate part of time beneath the stars. Not the science, not the structure, but the feeling. The sense that in every quiet night, in every silver shimmer across the sky, there is something personal unfolding. We often think of time as a taskmaster, a keeper of deadlines, a ticking echo in the back of our minds. But beneath the stars, time loosens. It stretches. It breathes. It becomes something we inhabit, not something we chase. In the hush of night, where human voices fall away and only the sky remains, you begin to notice things differently. A single second can feel long, full, and rich, and a minute can slip by like a sea. You feel not the pressure of time, but its poetry. This poetic time is something our ancestors knew well. Before electricity, before screens, they lived by natural rhythms, sunlight, moonlight. Their evenings were illuminated not by artificial bulbs, but by the slow reveal of the cosmos. They watched the constellations return each season, like chapters in a familiar story. They sat beside fires, tracing myths across the stars, naming them, breathing life into them. And in doing so, they found meaning in the pattern. They saw their lives mirrored in the sky, the loss of a loved one, the birth of a child, the harvest and the hunt. All were marked not by numbers, but by the sky's shifting dance. Time was sacred, not because it was rare, but because it was shared, with each other and with the stars. Today, though the world has changed, the stars remain. They are the same lights our ancestors looked upon, the same lights we now measure with satellites and software, but their essence hasn't changed. They still keep time in the same way. They still return in their patterns, unbothered by the chaos below. When we step outside, away from the noise, and look up, we connect with something ancient, something unchanging, and in that connection, something deep inside us relaxes. The tension of our modern hours begins to ease. The anxiety of the next task fades, because the stars are not concerned with urgency. They teach us to wait, to observe, to listen. And in doing so, they remind us that not all time must be filled. Some time is meant to be savoured. Astronauts often speak of this when they return from space. They say that seeing Earth from above, against the backdrop of the stars, changed them, that they felt small but not in a diminishing way, in a way that expanded their hearts. Time in orbit, they say, feels different. Days pass quickly with the rising and setting of the sun every 90 minutes, but the presence of the stars beyond the window is constant, unblinking, infinite. In that stillness, many astronauts report a kind of awakening, a realization that time on Earth is precious, fleeting, and far too often rushed. They come back slower, more patient, more connected, because they have lived, even for a short while, completely beneath the stars. Back on Earth, we can taste a hint of that perspective. All it takes is a quiet night, a patch of sky, and the willingness to be still. Lay back and let the stars come to you. Let the cool air fill your lungs. Let the distance between you and them soften, not as a gap, but as a bridge. And as you watch, you may notice something small but profound. The stars are moving, slowly, steadily across the sky, not because they are changing, but because you are. The Earth turns, you hide it, and the stars trace their arc because of your own motion. You are never still. Even when you feel still, you are spinning at 1,000 miles per hour, orbiting the sun at tens of thousands more. Yet the stars hold steady, providing the backdrop to this grand ballet. And through them, we measure not just motion, but meaning. In the most ancient star maps, the constellations were more than lines. They were characters, dreams, warnings. Orion the hunter chasing the Pleiades, Scorpius rising just as Orion sets, forever avoiding each other. These stories were born of people staring upward, night after night, until the sky itself became memory. Those myths may no longer guide our crops or predict our fortunes, but they still offer something. They offer a human fingerprint on the stars, a reminder that we are not just observers, we are storytellers, and our stories, when told through the stars, become timeless, passed down not in books, but in gazes, in shared silences, in the soft pointing of a child's finger at a first sighting of the Milky Way. Even science, in all its precision, does not strip away this wonder. It deepens it. Knowing that starlight is old does not make it less magical, it makes it more miraculous. Knowing that it took millions of years to arrive at your eye means that this moment, this exact second, is the completion of a journey longer than human history. What else in your life has travelled so far just to meet you? What else has waited so long to be seen? The sky becomes a gift renewed every night and offered freely to anyone willing to look, no matter where you are on Earth. Whether city or countryside, mountain or valley, the stars are above you. The same stars, the same ancient light. And though some may be hidden by haze or buildings or glare, they are still there, waiting. So what is time beneath the stars truly? It is not only seconds or hours. It is not the clicking of gears or the buzzing of alarms. It is a presence, a feeling, a way of being that honours slowness, embraces quiet, and welcomes wonder. It asks nothing from you except attention, and in return it offers peace. It tells you that you are not late, that you are not behind, that life is not a race to be won, but a path to be walked slowly, with pauses, with breath, with eyes lifted. The stars are older than anything you know, and they will outlive every moment of urgency you feel. Their time is not hurried, and neither perhaps should yours be. So let your evenings stretch. Let your thoughts drift with the constellations. Let your days end not in noise but in stillness. Watch the stars as your ancestors did, with wonder, with gratitude, with love. They have always been there, patiently guiding, silently glowing. And as long as you are willing to lift your gaze, they will be your reminder that time does not have to rush. It can glow, it can wait, it can sing softly beneath the stars. Imagine for a moment a world where light moves slowly, not in a hurry to cross the room, not rushing through the sky, but drifting gently like mist curling between trees. We often think of light as fast, instantaneous even, flashing across space, turning night into day in the blink of an eye. But what if we told you that sometimes in the hidden folds of nature light seems to pause, to hesitate? There are places where light lingers, trapped or delayed, slowed not by fatigue, but by the strange properties of the matter it encounters. These are not stories of imagination, but of science, soft revelations that tell us light is more than just speed. It is a substance of mystery, a traveller that sometimes forgets to hurry. In the deep heart of certain cold gases, scientists have created conditions where light can be slowed to a crawl, mere meters per second. In these labs, a beam of light, once unleashed at nearly 300,000 kilometers per second, begins to inch forward as though lost in thought. These experiments, delicate and precise, involve clouds of ultra-cold atoms nearly at absolute zero. At such low temperatures, atoms barely move, and when light enters their world, it does not travel freely, interacts, it dances, it gets absorbed and re-emitted, over and over, each time with a tiny delay. And through this slow waltz, its pace diminishes. It doesn't vanish. It changes character. It becomes patient. Even more astonishing, scientists have learned to stop light completely, to trap it within these cold atomic clouds and hold it still, as though catching a breeze in a bottle. For a few milliseconds, light rests. It holds its breath. Then when the conditions are right, it moves again, continuing its journey as if no time had passed at all. This is not science fiction. It is quantum physics unfolding in the quiet corners of laboratories, revealing that light is not just a wave or a particle, but a partner in the dance of matter and energy. It listens, it responds, it waits when asked. But such behaviour doesn't only occur in labs. Nature too slows light in gentle ways. When sunlight passes through water or glass, it bends, it changes direction. This is because it slows down, not drastically, but enough to shift its path. This simple truth gives rise to rainbows, to the shimmer of diamonds, to the bending of a straw in a glass of water. The slowing of light is what paints the world with optical illusions, reflections and refractions. It is what makes sunsets so rich, casting light sideways through thick layers of atmosphere, slowing it, scattering it, colouring it with oranges and reds. Every time you see a halo around the moon, every time sunlight glitters beneath the surface of a lake, you're witnessing light in no rush, light choosing beauty over speed. Slower light gives us vision. In your eyes, light must pass through curved lenses, bending as it goes, slowing slightly as it travels through different tissues. This bending helps focus images on your retina. Without it, the world would blur. And once light reaches your retina, it does not stop being light. It becomes something else. It triggers chemical changes, electrical signals, thoughts. The journey of light ends in the mind, transformed into sight, colour, emotion. But its delay, its slowing along the way, is what allows you to see clearly. In a way you do not see fast light, you see slowed light, light that has taken the time to share its message with your senses. Beyond Earth, in the cold depths of space, light takes its time in stranger ways. When it passes near a massive object, a planet, a star, a galaxy, it bends. This bending is not just a trick of perspective. It is a consequence of gravity slowing time itself. The stronger the gravity, the more time slows and the more light appears to curve. Around black holes, this effect becomes extreme. Light can orbit a black hole in a perfect ring, caught between falling inward and escaping. This ring, known as the photon sphere, is a place where light circles endlessly, forever caught in gravity's grasp. Here, light truly forgets to hurry. It is suspended not by choice, but by the structure of space-time itself. This interaction between light and slowness gives us new ways to see the universe. Astronomers use gravitational lensing, light bent and delayed by massive galaxies, to detect things too far or faint to observe directly. The delay gives them time, the bending gives them clues, and sometimes, when light from a distant quasar takes multiple paths around a galaxy, it arrives at Earth at different times. We see echoes, multiple images of the same event, spaced apart by hours, days, even years. In this way, the universe writes its story not all at once, but in overlapping waves. A single event becomes many, spread across time by the quiet delay of light. All of this reminds us that speed is not always the goal, that sometimes the most revealing moments are the ones that unfold slowly. When we rush through life, we miss the details, but when we pause, when we slow, we begin to see things more clearly. Light teaches us this. In its rare, slow states, it becomes a teacher of patience. It shows us that even something born in a furnace travelling at impossible speed can find stillness, can be held, can be transformed by the world around it. The slowing of light also offers the potential for new technologies. Optical buffering, quantum information storage, advanced communications all become possible when we can slow, stop, and resume light. We may one day build computers that use light instead of electricity, storing data not in silicon, but in beams frozen briefly in atomic clouds. Information would move at the speed of light, pause when needed, then continue on. This future begins with understanding how light behaves, not when it races, but when it rests. And still, beneath all the science, all the technology, there remains something poetic. The idea that even light, so pure, so fast, so constant, has moments of hesitation, moments where it lingers, where it is shaped by its surroundings, where it listens to the world and changes in response. Perhaps there is a lesson here for us. In the rush of days, in the spinning of thoughts, in the blur of one moment into the next, we too might find value in slowing down, in pausing, in letting the world shape us gently before we move on. So the next time you see sunlight filtering through a curtain or moonlight reflecting off wet pavement, think of it not as a flash or a beam, but as a traveller that sometimes forgets to hurry, a companion that, like you, is shaped by the path it takes, and in its pauses, its bends, its gentle delays, it leaves behind a kind of beauty that speed alone can never create. Let's drift deeper now into the secret world where light, when it slows, begins to whisper secrets that fast light can never tell. In its unhurried state, light reveals textures and subtleties that often go unnoticed. When it lingers, bends, or delays, it doesn't merely illuminate, it transforms the space it touches and changes the meaning of time itself. In certain materials like transparent crystals or chilled vapours, light slows dramatically. These aren't just strange tricks of physics. They are like small invitations to notice how delicately the universe moves when given time to breathe. Slowed light moves more like a sigh than a spark, more like a ripple across still water than a storm through air. And in this softness, something poetic unfolds. The moment begins to stretch. Reality becomes layered. You begin to feel that time, too, might be more fluid than we once believed. We often think of light as something that simply shines, but when it slows, it begins to listen. In optical fibres, which guide light across oceans and cities, tiny impurities or bends in the path create subtle changes in speed. These imperfections do not destroy the light, they sculpt it. They create dispersion where different colours, different wavelengths travel at slightly different speeds. This is why a prism can separate white light into a rainbow, why a soap bubble shimmers with shifting colours, why the sky can wear blue while the horizon glows orange. All of it is due to the way light stretches and slows in the presence of structure. And this is no accident. It is how nature writes with light. The shimmering of a dragonfly's wing, the iridescence of peacock feathers, the changing hues of opals, these are not pigments. They are architectures of light delay, and when we see them, we are seeing slowed light tell its story. Even in the natural world, this slowing becomes more than beautiful, it becomes vital. The chlorophyll in a leaf, for example, traps light for long enough to transform it into energy. This pause, brief but essential, allows the plant to perform photosynthesis, the quiet alchemy that fuels nearly every living thing on Earth. Without that moment of delay, the sun's energy would simply pass through, unnoticed, unusable. But because light can be held, bent, guided, it becomes nourishment. In this way, a single beam of sunlight, slowed for just a heartbeat of time, becomes a seed of life. When you eat fruit, when you breathe, when you walk through a forest, you are feeling the effects of delayed light, captured and woven into the fabric of living things. In our own bodies too, light is harnessed with exquisite care. The human eye is a marvel of delay and precision. Light enters, slows as it passes through the cornea and lens, refracts to focus on the retina, where cells called photoreceptors wait to receive it. These cells do not react instantly. They require time, tiny fractions of a second, to change their chemistry, to start a cascade of signals that become vision. These delays are not errors. They are the very basis of perception. The softness of twilight, the sparkle of a candle, the deep hues of dusk. All of these are made possible not by the rush of light, but by its willingness to slow, to linger, just long enough to be felt. Even in the way we think, light has a role. Our thoughts are built on electrical signals, but many of these signals are regulated by light-sensitive processes, such as our circadian rhythm, which tells us when to sleep and when to wake. Light enters the eye and signals to the brain that it is day or night, helping align our internal clocks with the world outside. But this too is not immediate. It requires time for light to pass through the eyes, be interpreted by the suprachiasmatic nucleus deep within the brain, and for hormones like melatonin to rise or fall. This slow dance between light and time is what helps us feel alert in the morning and drowsy at night. Without it, our inner sense of time begins to dissolve. On the edges of human technology, we are learning to hold light more carefully. Scientists have built optical cavities and resonators, tiny chambers where light bounces between mirrors, delaying its exit by nanoseconds or more. These delays are like echoes in a hallway, and they allow for precision in everything from atomic clocks to telecommunications. When we synchronize the timing of computers or networks across the world, we are often using light that has been gently slowed. In this slowing, we find clarity. The world becomes more orderly, communication becomes more accurate. Even the internet relies on these delays. Without them, our messages would collide, our data would blur. And in the most extreme places, like near a black hole, time itself slows to a crawl. Light, trying to escape, becomes redder, stretched out, weakened. It may take years, centuries, or forever to reach a distant observer. In the heart of a black hole, time stops completely, and light, if it could be seen, would be frozen in place. This is not an illusion. It is the deepest truth of general relativity. Time and space are not separate, but woven together, and light is the thread that binds them. When gravity grows strong, the fabric bends, and light, like a bead on a string, follows the curve. We measure these curves not just with equations, but with telescopes that read the delayed light of stars, quasars, and galaxies far away. The delay tells us how much the universe is stretched, how fast it's expanding, how long ago the first stars burned. It is a delay that tells us our own origin. There's a quiet irony in all of this. The fastest thing in the universe, light, is most meaningful when it slows down. We learn the most not from its rush, but from its patience, from the way it bends and lingers, echoes and refracts. The world's beauty, the sparkle of snow, the glow of dawn, the shimmer on a river, depends on this softness, the way that light becomes less like a race and more like a whisper. And in this whisper, we begin to hear something that is not just science, but something emotional, something close to wonder. A pause of light is the pause of life, a stillness in which we remember how to feel. So take a moment now. Think of all the ways light slows in your world, the way it lingers in golden hour shadows, the way it shifts through a stained glass window, the way it flickers on a candlelit wall. These are not just accidents of physics, they are invitations to stop, to notice, to breathe. Slowed light reminds us that not everything meaningful must be fast. That delay can be beautiful, that slowness can be sacred, and maybe As you sit in that gentle glow, you'll feel it too, that soft truth hidden in the beams that take their time to arrive. When light forgets to hurry, we remember how to be still. Let us now gently come to rest in the final curve of this journey, where light, in all its softness and delay, reveals something not only about the universe, but about ourselves. When light forgets to hurry, when it chooses to linger in the folds of time and matter, it teaches us to listen more carefully. We begin to understand that the world isn't only built from speed and motion, but from pauses, those quiet, suspended moments that stretch longer than they seem, carrying more than they show. Just as light, when slowed, holds information about its source, about the path it travelled, and about the space it passed through, so do our slowest moments often carry the deepest meaning. The still gaze between two people, the long breath before a word, the silence after a song ends, all of these hold the same quiet magic. They are not voids, they are full. They are reflections of the same phenomenon we see when light takes its time. And what happens when it does? When light is not simply a flash but a lingering presence. It begins to reshape not just the world around us, but the very shape of time itself. In optical experiments where light is delayed, we learn that time is not uniform, that it can be stretched and folded, compressed and replayed. These aren't just lab tricks, they're insights into the nature of reality, clues that our most intuitive sense of time, with its ticking seconds and flowing hours, may be only one perspective. Perhaps, like light, time can move differently depending on where you stand, how fast you move, or what surrounds you. A clock on a mountain ticks faster than one in a valley. A satellite feels a slightly different time than your kitchen wall. In slowing light, we have found a key to unlocking the malleability of time, and in that, a doorway to a new way of feeling life. Even the light inside your technology, the gentle pulse that flows through fibre optic cables, through LED screens, through the sensors in your camera, depends on control. Engineers bend light, trap it, delay it, reflect it in tiny patterns so precise that whole conversations can travel invisibly between continents. When you send a message, you send light, and that light, though fast, obeys rules that allow it to pause in transit, to be held and then released again, like breath. Your voice, your laughter, your thoughts can be turned into pulses of light that wait briefly, journey far, and then reassemble on the other side. This is no small thing. It means that every day, across the world, light is paused. Not endlessly, but just enough to hold human meaning. Emotion, memory, connection, all carried inside photons that forgot to rush. But this is not only true of artificial systems, the same is true in your own body. Inside your brain, countless interactions happen at the speed of thought. But many of those signals rely on chemical delays, on feedback loops and slow cascades that create rhythm and coherence. Your mind is not a blur of electricity, it is a tapestry of timing. And much like light that pauses in glass, your thoughts require these delays to make sense. If everything happened instantly, there would be no shape, no order, no memory. Delay here is not failure. It is what allows you to feel music, to follow a conversation, to watch the sky and call it beautiful. The rhythm of perception, of understanding, is built on the same principle that governs the soft slowing of light. The right moment arrives not when it's fastest, but when it's felt. So now let's return to the heart of the idea, that light in all its glory, sometimes slows. Not because it must, but because it can, because the universe allows it. And in those moments, we are given a glimpse of what might lie beneath the rush. The firefly that hovers just a second longer in the air, the glint of sunlight on frost that seems to shimmer in place, the golden hue of late afternoon where shadows stretch lazily across fields. These moments exist because light did not hurry, because it paused, bent, and in doing so painted scenes that feel eternal. When we remember those moments, it is not their clarity or detail that holds us, it is their stillness, their quiet refusal to move on too quickly. They felt somehow outside of time. In a world that often glorifies speed, fast answers, instant replies, immediate gratification, there is something deeply healing about slowness. Light shows us that speed isn't always strength, that delay isn't always weakness, that in taking time, in stretching out a moment, we might see things more clearly, we might understand them more deeply. This is the message of a rainbow, of a prism, of a shaft of light filtered through mist. Take a breath. Let the moment unfold. Don't rush through it. Let it bend, scatter, soften. Let it hold you. And what does this mean for how we live? It means we can let go of the need to always move quickly. We can embrace time as a partner, not a pressure. We can find comfort in the pauses, in the long walks, in the slow meals, in the quiet hours beneath the stars. Light reminds us that even something born in the core of a star can find stillness, that even photons, those tireless travellers, can wait, that beauty does not need to be loud or fast to be profound. This truth is woven into nature itself. The glow of bioluminescent algae, the gradual unfolding of a sunrise, the long delay between lightning and thunder, these are all examples of light taking its time or being echoed through time. And when you witness them, something in you settles. You feel, without knowing how, that the world has space for your slowness too, that you don't need to be rushed, that waiting can be full of meaning. So let this be your invitation, to see light not just as something that races, but as something that rests, to notice the moments when brightness lingers, to cherish the delays, to see in every reflection, every flicker, every slowed beam of light, a reflection of your own need for stillness, a mirror to your own breath, a rhythm that asks nothing more than for you to be present. Because when light forgets to hurry, it brings the world into sharper focus. It reveals the details. It soaks the ordinary in gold. And maybe, just maybe, it reminds us that we are not alone in our need to pause. That the universe, in all its vastness, has made space for waiting, for feeling, for noticing the quiet light that lives between the seconds. And so, as this journey ends, let it end gently. Let it end like light through a curtain, like the last glow of twilight on your face. Let it slow and slow again until it simply rests, not gone, just here, still, patient, waiting with you in the dark. Deep within the smallest packet of light, a photon, there may exist something we do not fully understand, something that ties motion, time and energy into a thread too fine to see. A photon is often described as timeless, a traveller that is born and arrives in the same breath, experiencing no passage of time along its path. But there is a lingering question, one that quietly pulses beneath the surface of physics. What if the photon carries a clock inside it? Not a ticking watch or a wheel of gears, but a rhythm, an internal frequency, a hidden beat, as if light itself is humming. The idea is subtle, almost poetic. Each photon with its energy has a frequency, and frequency is, in a sense, time, measured in cycles, in repetitions, in the gentle turning of an invisible hand. When you see colour, you are seeing frequency. Red light has fewer waves per second than blue light. Ultraviolet, invisible to the eye, hums faster still. These frequencies define the photon's identity. They are the very fingerprint of its energy. And yet these cycles are not waves on a pond or visible ripples in the air. They are probability, vibration, essence. And if we imagine that frequency as a kind of clock, a repeating pulse inside the photon, then we begin to wonder, does light carry its own time with it? Not time as we know it stretched between moments, but time as rhythm. A music that the universe listens to but does not measure with seconds. In the realm of quantum mechanics, the photon is a curious creature. It has no mass, no rest frame, and it always moves at the same speed in a vacuum. Because of this, it experiences no time in its own journey. From its point of view, if such a view exists, it is emitted and absorbed in the same instant. There is no in-between. But outside the photon, from our view as observers rooted in time, it takes seconds, minutes, even years to arrive. Light from the nearest star takes 4 years, from distant galaxies, millions or billions. But does the photon itself remember that journey? Does it carry something within, some imprint of time, however strange or folded? Some physicists propose that the frequency of a photon is more than a mathematical trait. It is its clock. It is how the photon knows itself. That frequency is not just something we observe, but something the photon lives by. When it interacts with atoms, the matching of frequencies governs what is absorbed, what is emitted, what is reflected. It is like a dance, where each photon carries its own tempo, and only atoms tuned to that tempo will respond. This invisible rhythm becomes a form of time, not in seconds, but in suitability, in resonance, in harmony. When you look at a glowing ember, a flickering screen, a shaft of sunlight through leaves, you are surrounded by photons, each with their own frequency, their own tiny ticking, and while they experience no time themselves, they carry within them a kind of order, a way of unfolding that gives the world its form. Without these invisible clocks, colours would not exist, temperature would have no meaning, photosynthesis would not happen, life would lose its spark. The frequencies carried within photons determine how energy is shared, how atoms behave, how warmth and light move through air and skin. In this way, the photon's internal rhythm becomes the heartbeat of matter. Even the concept of temperature is tied to these invisible cycles. When something is warm, its atoms move more quickly, and they emit photons of higher frequency. The glow of a heated object shifts from red to yellow to white, and even into blue. This isn't just brightness, it is information. The object is humming at a higher tempo. Its photons are beating more quickly, and those beats, carried in waves across the room, touch your skin and tell you, this is warm. The photons reach your body, their tiny clocks transferring energy in an invisible rhythm that becomes sensation. This is not just heat, it is time arriving on the back of light. And when light interacts with gravity, its frequency shifts. As it climbs out of a gravitational well, it loses energy, its frequency decreases. This is known as gravitational redshift. As light falls into a gravity well, its frequency increases. In both cases, the photon's clock is altered, as if space-time itself is reaching in and turning the dial. This tells us something profound. The universe is not a place where time and energy float freely. They are deeply connected, bound together by light. The tick of the photon changes depending on where it travels, what it passes through, and what it encounters. And in this, we see again that light is more than motion. It is memory, it is rhythm, it is the thread that pulls time along its path. We use this principle in our most precise timekeeping. Atomic clocks used to regulate GPS, international time standards, and scientific measurements are not based on ticking hands or swinging pendulums. They are based on frequencies of light emitted by atoms. Cesium, for example, emits radiation at an exact frequency, 9,170 times per second. That number defines 1 second. It is light's rhythm that gives us time. Without it, we would drift. Our systems would lose sync. Our maps would skew. Light becomes not only the traveller, but the measure of the journey. And all because inside the photon, there is something that repeats, something that pulses, a clock without hands. This idea of a clock inside a particle feels strange because we are used to clocks being external. But in nature, timekeeping is often internal. The cycles of sleep in animals, the blooming of flowers, the migrations of birds, all are governed by internal clocks. Why not photons too? Why not light, carrying within itself a silent metronome, ticking not in hours but in hearts, in repetitions per second so small, so fast we can only detect them with instruments and mathematics, and yet without them there would be no time to tell. So the next time you look into a beam of sunlight or see a glimmer on water, imagine this, that every glint is 1,000 rhythms playing at once, that the light is not just moving but singing, each photon humming its frequency, each carrying its invisible clock. And though those clocks experience no time themselves, they shape the time we know. They build it second by second from the pulses of light that fall on your skin, on your eyes, into your memory. You are wrapped in this rhythm. You're made of it. And even though we may never open a photon and find a ticking mechanism, the truth remains. Light tells time, not just for us, but for the universe. And in the quiet pulse of its frequency, something beautiful happens. Time becomes not just a line, but a music, not just a measure, but a meaning. And you, breathing softly in its glow, are part of that melody. Let's now wander further into the depth of this idea, that photons, the tiniest flickers of light, carry within them an invisible sense of rhythm, a clock that ticks not in seconds but in cycles. To the eye, a photon is colourless. To the mind, it is mysterious. And yet, through the lens of quantum physics and wave mechanics, it reveals an order so elegant, so profoundly consistent, that it rivals the finest clock humanity has ever built. Every photon, regardless of where it comes from or where it travels, carries a frequency, a number of vibrations per second, that defines not just its energy, but its identity. In these vibrations we see a kind of time, not a linear passage from past to future, but a contained, cyclical beat that says again and again, I am here, I am this, I am now. We live our lives within this unseen architecture. The warmth on your skin from the afternoon sun is a feeling shaped by the tempo of infrared photons. The glow of a blue sky, scattered by the atmosphere, is built from higher frequency photons dancing with air. Even the colour of the world around you, the red of an apple, the green of a leaf, the blue of your favourite shirt, depends entirely on how surfaces reflect and absorb photons of different frequencies. And though we do not hear them, each of these photons sings. Their frequency is their voice, and their voice becomes the palette of vision, the texture of warmth, the rhythm of life. Inside the deepest chambers of scientific exploration, this understanding becomes a tool. Lasers, for instance, are precise not because they are bright, but because their photons are all the same, travelling with perfect synchronization. They are not scattered in their frequencies, but unified. It is as though all the photons in a laser are ticking to the same exact clock, moving in lockstep, like dancers guided by an invisible drum beat. This coherence makes lasers powerful tools, used for everything from delicate surgery to measuring the movement of tectonic plates. It also reveals a truth about light itself, that when its clocks align, its power multiplies. The synchronized hum of photons becomes more than light. It becomes control. And yet this idea extends even beyond photons. It leads us to a greater truth about the universe. That everything is vibration. Every particle, every atom, every molecule pulses in some way. Strings in string theory are said to be tiny vibrating loops. Electrons can be described by wave functions, patterns of probability that oscillate. Even space and time themselves, in some theories, may emerge from more fundamental rhythms. In this view, the photon's frequency is not an exception, it is a reminder. A reminder that at the heart of all things lies repetition, a gentle, persistent ticking that builds matter, energy and time from invisible cycles. In astronomy, this rhythmic nature of photons becomes a tool for exploring the cosmos. When we observe distant stars or galaxies, we often look not just at their light, but at how their frequency has changed. If the light is redshifted, its frequency lowered, it means the source is moving away from us, stretched by the expansion of the universe. If it is blue shifted, its frequency raised, it means the object is coming closer. These changes are subtle, but they carry immense meaning. From them we learn how galaxies drift, how stars dance around one another, how the universe itself is growing. Each photon, arriving after millions or billions of years, still remembers the frequency it carried when it began. It tells us not just what it is, but where it's been, and how the space between has changed. In this way, photons become messengers not just of light, but of time. Their internal clocks, those silent frequencies, hold the story of their journey. We can read that story in a lab or through a telescope, or in the way our bodies respond to sunlight. And when photons pass through different materials, glass, water, crystals, they slow down, as we have seen. But the frequency remains unchanged. Their internal ticking doesn't alter, even as their speed does. This constancy is key. It means that even as light bends, delays, or refracts, it retains its identity. It stays true to its inner rhythm. And so it becomes not just a traveller, but a reliable companion, a light that carries time without ever aging. Even in the study of atoms, the photon's frequency plays a central role. When an atom jumps from one energy level to another, it emits or absorbs a photon with a specific frequency. That frequency is not random. It is precise, exact, tied to the difference between the atom's states. This is the basis of spectroscopy, a science that lets us identify elements in distant stars, analyze chemical compositions, and even detect planets around other suns. Every element has its own set of frequencies it responds to, its own musical scale, its own inner harmony. and photons are the notes that play those songs. The universe becomes a symphony of interactions, and light is the music. So what does it mean to say that a photon has a clock? It means that within its vibration, its repetition, its frequency, there lies a rhythm that governs interaction, communication, even memory. It means that even though it does not experience time, it helps create time, not in the way a second hand marks a moment, but in the way a drum beat marks the shape of a song. Time in this sense is not a line we walk, it is a pattern we dance to, and photons are both the dancers and the tempo. This idea touches the poetic as much as the physical, because if light carries time and if we are made from light, shaped by it, warmed by it, guided by it, then perhaps we carry that rhythm too. Perhaps our own sense of time is not just chemical or biological, but photonic. Perhaps we are tuned to certain frequencies, drawn to certain rhythms in ways we don't fully understand, the way music affects us, the way sunlight soothes us, the way certain colours stir our emotions. Could these be echoes of the photon's internal clock? Could our very moods rise and fall on the waves of invisible rhythms passing through us? It's a tender thought. That light is not just around us but inside us. That every cell, every heartbeat, every dream is touched by the clocks inside photons, ticking quietly at the edge of perception. And though we may never hear that ticking, we live by it. We wake and sleep by it. We build and remember and hope by it. The universe pulses, and we pulse with it. And the photon, that smallest sliver of light, carries the beat. Now let us arrive gently at the final folds of this quiet journey, where the clocks inside photons, though silent and unseen, continue to ripple through every part of our lives. To think of light not just as illumination but as a keeper of rhythm reshapes the way we understand everything from colour to consciousness. We often imagine light in terms of what it reveals, how it paints our world with brightness, how it allows us to see. But what if its deepest power lies in what it keeps? A frequency, a beat, a memory, a map of time itself. The photon, moving at the speed of light, exists outside our flow of seconds and minutes, yet paradoxically becomes the very foundation upon which we define those very units. It travels without experiencing time, and yet gives us the ability to measure time with breathtaking precision. This paradox is not a contradiction, it is an invitation to look closer, to feel more, to see time not just as passing but as present in everything that moves. Consider again the atomic clocks that shape our modern world. Their heartbeat, the thing we trust above all else, is measured not by a mechanical tick, but by light. A specific microwave photon, emitted as an electron in a cesium atom moves between two energy levels, defines the second. It is light that measures the rhythm, and the reason we trust it is because that photon's frequency never changes. It may travel through air, vacuum, or fibre, but its internal beat remains untouched. This is not a fragile rhythm. It is the most consistent rhythm known to humanity, and every phone, every GPS system, every scientific experiment that relies on exact timing is held together by this quiet, perfect pulse. And what of memory? What of the way we store not only data but meaning? Increasingly, our world relies on photons to carry information. In fibre optic cables, trillions of bits of data stream across oceans and continents as pulses of light, each encoded with tiny shifts in phase and frequency. These are not mere blinks, they are structured, rhythmic signals, each pulse a whisper of something once spoken, written, recorded. The photons themselves do not age, do not remember, but in their movement, in their frequency, we record our memories. Human history in this era is being written in light, and still deeper down there's something more mysterious. Some scientists speculate about the idea of a fundamental time, the smallest possible unit beyond which time has no meaning. This Planck time is unimaginably brief, about 10 to 44 seconds. At this scale, time may no longer flow but flicker, and the photon, with its inherent frequency, may be one of the few entities that bridges our everyday world to that hidden realm. Its frequency links energy, mass, time and space in a single, unbroken thread. In this way, the photon's clock is not just a metaphor, it might be a bridge, a way of touching the edge of what time really is. We may never open a photon and peer inside, but in the way it behaves, in the way it interacts with matter, with atoms, with us, we see the outline of something clock-like, something ordered, something regular. And in that regularity we find comfort. The sun may flare and fade, the earth may wobble and shift, but the frequency of a photon remains the same. It is the universe's soft promise of consistency, and perhaps in a world full of change, that's why we look to light, not just for sight but for certainty, for rhythm, for truth. In the natural world too, we see this rhythm echoed back. The wings of a hummingbird blur with such speed that they become a kind of visual frequency. The chirp of a cricket accelerates with temperature, its rhythm a biological clock tied to light and warmth. Human bodies, synced with the circadian rhythm, wake and sleep based on the changing colour of daylight. Every signal, every pattern, every cycle in nature seems to be dancing to some internal beat. And behind it all, light. Not just lighting the path, but setting the tempo. The photon may not know time, but it knows frequency. And in that frequency, the world finds its flow. Let us step even further into the poetic. There is something strangely tender about this, about a universe built not from chaos, but from rhythm, that what seems silent is in fact singing, that the very particles we cannot touch carry a tempo that holds us all together. Even the stars hum, not in sound, but in pulses of light and gravity. Our sun vibrates in patterns that radiate through space, and scientists have learned to hear its rhythms by studying oscillations in light. These vibrations reveal its internal structure, its age, its health. Stars speak through rhythm, and photons are their voice. And when those photons reach us, across light years, across centuries, they carry that song unchanged. We are, each night, bathed in starlight that began its journey before we were born. And even though those photons have no clock of their own, they arrive with their frequencies intact. They arrive not just as brightness, but as time preserved. They remind us that even though we age, even though our clocks tick forward, some things remain steady. Some rhythms, once set in motion, are never lost. This is not just physics, it is a kind of grace. The idea that something so small, so swift, can hold the pattern of eternity within it. That photons, light itself, can move without time, yet shape the very structure of time for all things that follow. And if that is true, then perhaps we too carry clocks within us. Perhaps our own memories, our own intuitions, our own experiences of beauty are shaped by the same invisible pulses. We resonate, not because we are made of light, but because we are made with it. So what do we do with this knowledge? Perhaps we become more attentive to the rhythms that govern us, to the light that guides us, to the moments when time feels slow, and we sense a deeper beat beneath the noise. Perhaps we learn to listen not just with ears but with hearts to the soft frequency of the universe, the one that hums through photons, through atoms, through stars, through us. And in the end, as the light continues to move, untouched by age, bearing the clocks we can't see but somehow feel, we begin to understand. Time is not just something we count, it is something we are part of. It flows through us, shaped by rhythms older than memory, steadier than breath. And every time we look at the sky, feel the sun, see a glimmer, remember a dream, we are touching the clock inside the photon. And maybe, just maybe, it is touching us back.